Hey kids! Today we're working on lesson 16 and we're starting kind of a new section in module 5 and it's about working with shapes. So we start with trapezoids and today you might notice that I'm using single sheets because my first video got eaten by the internet and so I was like, oh darn, but this will actually be better because I was kind of having a hard time getting my protractor to fit with the spine of the book. So anyway, you can also do that too if you have a printer, but it's totally not necessary. So we're going to start with having your tools. Make sure you have a protractor. This is going to help you measure the angles that we're going to create. And I'll show you how to use it when we start using it. And you don't need one of these. It's going to direct you to use a set square, but if you don't have one, you can survive without it. I just happen to have one as part of our student set. So we're going to start out with parallel lines. Now, a lot of these, the terminology that's used here is on the previous video with all the geometry terms, and I highly recommend that you watch that one. Record all of those definitions in a notebook, have pictures of them so that you can keep it in front of you while you're doing these tasks. And this is just a quick glance at that, but I have like 5 or 6 pages of geometry terms, and you really need to be sharp with those so that you know what I'm talking about. Okay, let's get started. So we're going to draw a pair of parallel lines in each box. Then use the parallel lines to draw a trapezoid with the following. So we're going to start with parallel lines. You can use your the base of your protractor, and what I usually do is I just go, okay, I'm going to go from say 3 to 6.5, and then without moving it, I'm going to go a wider or longer line on the bottom. Okay, and then close off these two sides, corner to corner or point to point. Okay, and so when I look at this, I want to create, here are my parallel lines, and I have no right angles. Remember, right angles are perfectly square corners. Then I'm going to have another set of parallel lines. They don't always have to be sorry, we'll get to the one obtuse angle. They don't always have to be just the regular flat, and so sometimes I like them to be crooked. So only one obtuse angle. Now, what does that mean? It means I have to actually think about this, because if I have only one, and typically I'm going to have 2 obtuse angles at the top, then what I need something that is exactly below, so that I will create this corner that is a 90-degree corner, so that I can show you, here's my obtuse angle. That's really big, but these two here are going to be the square corners where it will slice straight across perpendicular to the line, the parallel lines. Okay, so this one and this one, these are parallel lines. This line is perpendicular to both. This is my one obtuse angle, and this is my acute angle. And so if you go back, you see, well, I have 2 obtuse angles here, obtuse, and then acute, acute. This has no right angles. This one has 1. So what's next for our instructions? 2 obtuse angles. So we have basically a regular trapezoid, but it doesn't have to be quite as regular as this one. And so we'll shape this one a little differently. And then remember, without moving it. So for this one, I have a little bit longer on this end and a little bit shorter here. It's still a trapezoid, because the definition of a trapezoid is it has only one pair of parallel sides. Okay, so I still have 2 obtuse angles. These are going to be on the top, which it has to be greater than 90. It only has to be 91 to be greater than 90, so these 2 are obtuse. and then at least one right angle. So here I'm going to show you with parallel lines first, and then I'm going to go straight down and bring this out, connect these endpoints. Okay, now what happens if I have, I'm going to use my set square. The set square is kind of nice because it will allow you to look at these corners. Okay, so if you want to put this right on the line, then you can see exactly where that straight line would cross. And so that's where it would be. So if it has one right angle, and it doesn't really matter where you put it, there's no way you cannot get a right angle on the other side, okay? Because this line here is what's called perpendicular to the parallel lines. It has to be perpendicular to give you this right angle here. Therefore, it has to be perpendicular to this one too, because these lines are parallel. Okay, so if you have at least one, you can't only have one. Can't only have one. Okay, you will have two. So mark that down so that you know you will have two. Look, just like up here, we tried to do one, but we couldn't not do it. So every time you have that perpendicular line, you have two. Now, on the back, if you flip that page, we're going to be doing these tasks with the trapezoids that you made here. So keep this handy. Use the trapezoids you drew to complete the tasks below. Measure the angles of the trapezoid with your protractor and record the measurements on the figures. So you're going to take your protractor. Okay, I'm going to scooch that over. And one thing that you want to do when you measure angles is you're going to need to extend these lines so that you can have the ray going far enough to measure it. Notice when using the protractor, I'm using it as a ruler sometimes too, which it has all the centimeters here and inches here. Watch what I do with this little hole here. This is going to be right at the vertex. Put your pencil on that point. Notice how this black line here is pointing at 180 and 0. Okay, so you want to put that black line right on your trapezoid line. And once it's directly on that line, now I can look at this angle this way and follow the ray that goes up to the degrees. So this is 0, and we're going to always start with 0. So 0, 10, 20, 30, 40, 50, 60. And so how far out does it go? 61, 62, 63, and it's about 64 degrees. This angle is 64 degrees. Let's do that again. Extend this line out. Okay, just fling it out there. It doesn't, get it out there. Like, don't make it down here because that won't be long enough. Put the hole, if you have one of these, some of the protractors will have like a little divot right at the bottom, and this is your 0 line. You have to put it right where the point is, and then watch that black line and even it up. Okay, and this one is actually pretty close, and we're going to call this, look at how I'm going the other direction. So this is on the inside, 10, 20, 30, 40, 50, 60, 65. 65 degrees right there. Pretty close, but off by 1. So if you measure the angles and you record the measurements, we have to do all 4 so that we can talk about the adjacent angles. I'm just going to flip my paper so that I can use my protractor and you guys can read it. Okay, so I'm going to extend this line out so that now you can watch as I put this right on the vertex point, and it's going to shoot all the way out this adjacent angle to the 65. And notice how I go out to the 0 and I go all the way past 90 this time because this is a big wide open obtuse angle. Past 90, 100, 110, and 115. 115, and that's upside down, but I'll fix it later. And then this one is also going to need to be extended. Just way out there. You can always erase it later if it's in the way of something else. Put your vertex point right here. Make sure your line is on 0. And then measure this one. And this one we were off by about 1 degree. And so since I'm short by 1, I'm thinking I might need that extra 1. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 110. And then we're going to do right there, and we'll call it 116. So it's almost perfectly symmetrical. I could probably fudge it and say that it is symmetrical. But these are my obtuse angles. Here and here. And when you add them together, the goal, remember, is that adjacent angles should add up to 180 degrees. And so our next task, if you take a look, we're going to go back to this. We recorded the measurements, we measured the angles, and now we're going to use a marker or crayon to circle pairs of angles. We're going to have pairs inside each trapezoid with a sum. That's when you add, you get the answer, equal to 180. Use a different color for each pair. So I added up my 115 degrees here and my 65, and guess what? I got 180. So we're going to circle this pair with red because these two add up to 180. Then I'm going to look over here. Now, if I add 65 and 64, will I get 180? No, I'm going to get 129. Okay, so these are adjacent, but because they're both acute, they're not going to give me that 180. So it's only going to be the obtuse and acute together, not the acute or obtuse. You won't get 180 that way. It's got to be the neighboring angles that are the big, small on that same line. Then let's add the 116 and 64. 10, 6, 7, 8, and there's my 180. And so I need a different color for this one, this set. And in fact, I'm going to write it right side up so you guys can see that right there. And these two angles will add up to 180. So this is my adjacent pair, and this is my adjacent pair. Okay, very important. I know it's like, what, all this adding, but it's really very important. Used our different colors. Hooray, check that off. Check it off when you do it. Feels good. List the properties that are shared by all the trapezoids that you worked with today. All right, well, we have several things to note about the trapezoids. First of all, they all have how many sides? So we're going to always try to start with big descriptions. 1, 2, 3, 4, 1, 2, 3, 4, 4, 4. They all have 4 sides, so they're all quadrilaterals. Quadrilaterals. That means they have 4 sides. Okay, so that's one thing. What else? Well, they all have 1 pair of parallel sides. At least, at a minimum, 1 pair of parallel sides. Okay, and that is the, let me move that, that's going to be, this is parallel to this. This is parallel to this. Remember, 1 pair means you have 2 of them, like a pair of shoes. Pair and a pair. And these could be standing up. They could be turned this way. This is still a trapezoid. This is still a trapezoid. If it's upside down, it doesn't matter. It has 1 pair of parallel sides, and it's a 4-sided figure. Okay, you can turn these figures all around and it's still a trapezoid. Next question. Okay, what's the other thing that they have in common? Well, they can have different side lengths. You may not have noticed that, but they can have different side lengths. Okay, so unlike a square or a rhombus that have to have exactly the same length, trapezoids don't. They are not held to that standard. Now, when can a quadrilateral also be called a trapezoid? So we have to focus on just the one thing that makes it a trapezoid, and it must have at least one pair of parallel sides. And so the activities that we're going to be doing in this part of the lesson are always going to be coming down to the attributes that these shapes have. Okay, last one. Follow the directions to draw one last trapezoid. First of all, I'm going to move this. Second of all, I'm going to get my little set square as a ruler because we're going to draw a segment AB that's parallel to the bottom of this page that is 5 centimeters long. So I'm going to draw it, and I'm not going to start at 1 because that's a curvy edge. I'm going to go from from the 1 up to the 6. There we go. Okay, and this is a line segment, so I'm making it have like end points, and this line segment is AB, so I'm going to label this point A and this one B. This is parallel to this line, so we're all good. And it's 5 centimeters long. So let's label it since they have given us specific instructions. Draw two 55-degree angles with vertices at A and B. Vertices is plural for vertex, so that an isosceles triangle is formed with line AB, line segment AB, as the base of the triangle. So get your protractors. You need to create 55-degree angles. So let me show you how to do that. Super fun. Okay, again, vertex point right in the hole or on your baseline. And what you want to do is you want to use the inside on this one because we're trying to make 55 degrees. So it's not going to be 120 or 30 or 40. It's 55. How do you get to 55? 10, 20, 30, 40, 50, 5. Put a little tick mark right there. Now move your protractor. Put your pencil on that point and just draw a long line. Just super long. It doesn't have to connect to anything. Just draw the long line. That's a 55-degree angle right there. Now we're going to do the same thing on the other side. Protractor, vertex point on B. Put the line on 0. Okay. Count from 0 to 55. 10, 20, 30, 40, 50, 5. Go right to the middle point here, which is between 120 and 130. It's the same point for the middle between the inside and the outside. So you mark your point here. It doesn't matter that it's not inside the triangle. Don't stress out about it. Connect this point at B to the tick mark that you made. Doesn't matter that it's all hanging out up here. Does not matter. Got my 55-degree angles. Look how perfect that is. So that vertices at A and B, so that an isosceles triangle is formed. You should know what an isosceles triangle is because I gave the definitions on the previous video, which is two sides the same length. It's formed with line segment AB as the base of the triangle. Label the top of your vertex, top vertex of your triangle as C. Now this has to be the intersection here. So label it. Done. Use your set square, if you have one, to draw a parallel line, a line parallel to AB that intersects both AC and AB. It has to cross over, and it must be parallel to AB. If all of this talk is confusing you, okay, Go back and look at all the definitions because I'm going to be using all of these words again and again. Okay, so I drew a line that was parallel to AB. It intersected AC and BC. And now you may notice that we have a trapezoid. So your next task is to shade the trapezoid. And somewhere here I have a colored pencil that is very pretty. And I will grab that. And it's pink. And so we're using pink today. And here is the trapezoid that we just created with the parallel line, parallel to line segment AB, and it's a regular trapezoid because it has perfectly equivalent angles in the corners, so it's just a regular trapezoid. So that is how we do lesson 16. Lots of fun, and click subscribe and come back on more videos. See you on the next one.